Hi everyone, welcome back to our Leetcode Java challenges, and today we're going to pick yet another two most accepted questions. So last time I did this one. Either I missed that one or its acceptance rate changed. So let's try that one. I've got my ID with me if needed. That's a short question. That's always good. There's a biker going on a road trip and what? So we're given an integer array, this one, of length n. Okay, so n is this. What do I do with it? Net gain I is the net gain in altitude between I and I plus 1. Return the highest altitude of a point. Net being, it's not the highest, as in it's not the total value, right? So here's an example. We got an array. Output is 1. Why is it 1? Altitudes are 0, minus 5, because, well, we start at 0. Okay, yeah, that makes sense. Then the next one is minus 5 because we add 0 plus minus 5. Yep. And then the next one is plus 1, giving us the actual altitude of minus 4. Then it's plus 5, that gives us 1, plus 0 gives us 1, plus minus 7 gives us minus 6. Okay, that seems reasonably straightforward. We just need to figure out what the values, what the actual values are, and then from there just move to finding the maximum value in an array, I guess. So max is 0, and then we're going to return max. And we need to go through net. I'm going to call it offset because that is kind of, I'm used to this term rather than using the net gain. That means I'm going to start at 0. Actual is offset, right? And then if actual is greater than max, then max is actual. Do we know? Well, we start at 0, so it has to be 0. So it's the lower bound is 0. Which is why we're going to start at 0 here. That should be right. But this thing can be minus 100. So we can actually be at negative altitude potentially. So let's just make this something like minus 250. Alternatively, if you want to make really sure, then integer min value. I don't remember if it comes with the minus sign itself. I think it does. So let's try that. So that one got accepted. Let's try sending it for real this time. Wrong answer for what? For this one. So output is supposed to be -1. Wait, output is what we produced, -1. Expected 0. So it goes to -4, then we add -3, that gives us -7, -9, and then -10. So it never actually reaches. Okay. So yeah, we do need to include 0 at some point. As in, although we start with this kind of minimum possible value, we still need to take into account do we though? Let's just add 0, because that then would take care of itself, really. Yeah. Yeah, I'm happy with that. It's always better to know why something works rather than just producing something. So although the net values, the actual values can be lower than 0, we still need to take 0 into account because we start at 0. So that's the highest point in which case, the highest altitude. Right, let's do the next one. I wish they removed all the, can I sort this or filter this? There might be a way, but anyway, we'll just do it manually. So we've done that one, this one. Let's do the example first and then we'll go from there. Input, okay, so we get a string of words. What do we do with it? Output is 2. Transformation of each word is, yep, right, 2 different transformations. So a number of different transformations among all words we have. So National Morse code defines the standard encoding for each letter. Okay, so these are the mappings from 0 to 25 inclusive in terms of indices. If there are 26 items, we have last index at 25. Given a list of words, each word can be written as concatenation of each letter. C, A, B. So C is that one. Yep, and then A is this one. And then we have dash and triple dot for B dash triple dot. Yep, that works. Yep, got it. Transformation of a word. So basically convert a word into its counterpart in Morse code. Got it. What do we do next? Turn a number of different transformations. What do you mean number of different transformations? As in, if we reduce that, does it mean number of unique elements in a set containing all transformations? Is that what the question is? I'm going to assume that, and then we'll see if that works. So first transformations, we need to take an array of strings, which we have, convert that to another array of strings. This is where stream operations come in handy. I wonder if I should be using streams now. It's going to take longer though in terms of runtime. For now, let's just do the old school way and then we'll see. So transformations, new string, and it has exactly the same length. That's a bit better. So is transform words I. And then use something like set. Because set is defined to have unique elements. Yeah, I'm going to use my ID for that because that's much more convenient to write over here. Just something, I don't care, I just need the syntax. So this will work, this will do its own thing. We need a method, nope, that says transform. It takes a string, word, converts it to something. What else? And alternatively, we could just use a set. So string, right? New hash set should do it. Import this. And then we don't actually need that bit. We'll just transform and add it directly to the set. And then we return num unique elements is set size. All right, just read the documentation. Collection that contains no duplicate elements. So yeah, it matches the formal definition of a set, as in you would normally use in computer science. In which case we don't need this. And all we need to implement is this bit, because we return that one. And for that, we'll need all of these. All these are going to be stored somewhere. It's a map, right? So it's a string mapping to another string. Nope, it's a hash map. Let's go with that. Mores. And the question is, how do I put all of these Suppose I add this into an array somewhere. Would that work? Seems to be working. It's fine then, we don't need this anymore. And now I need to go through each element of this array in order. So, and I also need the alphabet. A, B, C. Or I could use just single string and then do this. B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. That should be 26. 26 characters. Yep, that's perfect. And now we're going to go through each element of this thing and then populate this map with ABC character at I converted to a string mapped against this thing, because we need characters to mores, yeah. And then transformation is we're going to go through each character. String result. The ID will shout at me for using string concatenation in a loop, but I'm not too worried. Word length. Character is that. And then result. Actually, I could have used the character to string. Character to string, in which case I can just put this. I'll just auto box it for me. Yeah. Result is morse get character, and then return result. So that works. Everything else hopefully works too. Now it's time to move all of this in the testing area. Let's do the imports first. And then we'll see how this goes. This is a class, so they are going to be constructing it, right? So what we could do is hook into the class construction and then populate this as needed. Now, if they're using the same JVM, then this is only going to be called once. So that's actually going to speed up a little bit, some things. But I don't think this is going to perform well. It's going to be quite slow, I would have thought. Yep, that looks fine. Then this thing goes away. That is fine. Private static. Yep, and void main is not needed because they're going to use their own one. Set. We don't need that one. Go through each word, we transform it, and we return this set size. Let's try that. Accepted. Nice. Submit. Two milliseconds. That's actually not bad. I wonder if this helped. Maybe it did. Anyway, so we are done. We've done 2 of these, and I'll be going through other things in the future video. There's a lot to go through. Right, thanks for watching. Hopefully you find this a little bit enjoyable, and I'll see you guys in the next video.